Okay, so for checkpoint 17, we have to remember the difference between and or, right? Whenever we see and in probability, we multiply, and whenever we see or in probability, we add. So for this first problem, it says that you've been asked to select a marble from a bag that contains 3 blue and 4 red marbles, and to flip a coin for heads or tails. So we're talking about two different events here. One is picking a marble, and then the other is flipping a coin. So when we look at the marbles, how many total marbles do I have to choose from here? 7, right? I have 7 total marbles. And when I flip my coin, how many different outcomes do I have? 2, perfect. So I have 7 marbles, and then I have 2 different outcomes I can have for my coin. So since this probability uses the word and means we are going to multiply. So all I have to do is 7 times 2, which gives me 14. So the sample space for this problem would be 14, meaning I have 14 different outcomes. Yes, question. Okay, so do you have questions on how I got 14, or are we okay? All right. So next one, for this problem, you got this one correct. Do you want me to go over how we get to this one, or are you okay? All right. Third one. Okay. Let's see. So, which answer correctly describes the probability of rolling a dice and landing on a number less than 4? Okay. So, when we roll a dice, I could land on 1, 2, 3, 4, 5, or 6. Which options are less than 4? 3, 2, and 1, right? So I can roll a 1, 2, or 3. So how many total options out of 6 is that? 3, right? And 3 out of 6 is 1/2, which is the same as like 50-50, right? I have a 50-50 chance. So that would be even. That would be even. Likely is more than 50%. So likely would be like rolling a number less than 5. So even is the term that they use for like 50-50. Alrighty, number 4 is asking us which event is a compound event. So compound events consist of you doing something more than once, whether it's rolling a dice 2 times. It could be something like drawing a card and then spinning a spinner. As long as you're doing something more than one time, it's a compound event. So for this first one, it says drawing a card that's a diamond, rolling a dice that lands on 1, flipping a coin that lands on tails, and the last one says flipping 2 coins that both land on heads. So out of those 4, which one are you doing 2 things in? Like almost like which one are you doing 2 experiments at the same time? The third one. So this one here says flipping a coin that lands on tails. When I read that, I think I'm only flipping 1 coin, right? So this last one would be the one that we're looking at here. So flipping 2 coins that both land on heads. So since we're flipping more than 1 coin, we're flipping 2, that makes it a compound event. All right, number 5. 5 says that zip codes are used throughout the United States to make the delivery of mail more efficient. Zip codes can break up the country into easily identified sections that contain certain addresses. The zip code is composed of 5 numbers. The first number can range from 1 to 9, and the rest of the 4 numbers in the zip code can range from 0 to 9. How many different combinations exist for a zip code? Okay, so I'm going to draw 5 blanks, and these 5 blanks represent the 5 digits in your zip code. It says here that the first number can range from 1 to 9. So how many total numbers do I have in that range? If I can have any number from 1 to 9. Perfect. So I can pick 1, 2, 3, 4, 5, 6, 7, 8, or 9, right? Because it's 1 to 9. So if I were to count all of those, I would have a total of 9 different numbers I could pick from, right? Not 0, because the first one is only from 1 to 9. It's not including 0 yet. That's the first one. But if we read this carefully, it says that the last 4 can be from 0 to 9, right? So any of these 4 blanks can have numbers that are from 0 to 9. So if I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different numbers I can choose from. Right, so for all of these other blanks, I have 10 different numbers that I can put in those blanks. So to figure out all of the different combinations, once we know all of these numbers, right, for each of the blanks, all we have to do is multiply all of them together. So 9 times 10 times 10 times 10 times 10. And I get 90,000, which means that there are 90,000 different zip code combinations. Yeah, wow, there's a lot of them, right? The same type of concept with cell phone numbers. There's tons of them. All right, number 6. Number 6, we went over in the open session. So for this one with the vowels and the numbers is 10. Do you want me to re-go over how we get this 10, or are we good? Okay. Number 7. So number 7 says that a bag contains 5 black marbles, 7 blue marbles, 3 green, 4 red, and 1 white. A marble is selected, then replaced, and a second marble is chosen. What is the probability of selecting a black marble and then a red marble? Okay, so we're doing 2 different experiments here. We're picking a marble twice, right? So this is a compound probability. When you read this probability question, do you see the word and or in it? Which one's breaking up our 2 events? Is it and or or? And, right? And means that we're going to do what? Multiply or add? Multiply. Perfect. So what we need to do is figure out the probability of picking a black marble, the probability of picking a red marble, and then just multiply them together. So in this bag, I have 5 black, 7 blue, 3 green, 4 red, and 1 white. So I need to figure out the total number of marbles that I have in my bag. So to do that, we would just add up all the colors, right? I would have 5 plus 7 plus 3 plus 4 plus 1. When you add all of those together, you should get 20. This is for black marbles, and this will be for red marbles. So there's still 20, so I have 20 in the bottom. Now the only thing that's going to change here is the number in my numerator. In that bag, how many black marbles do I have? In my bag of marbles that I have here in this problem, how many of them are black? 5, which means I would have a 5 out of 20 chance of choosing a red marble. And how many of them are red? 4, which means I would have a 4 out of 20 chance of choosing a red marble. Do you have questions on how I got either of these probabilities here, this 5 over 20 or 4 over 20? Okay, so now again, since our probability used the word and, that means we're going to multiply them. All right, so I have 5 over 20 times 4. Okay, sorry. I closed the program. We're good. Don't worry. I don't know what button I put. We're fine. Okay. So 5 over 20 times 4 over 20. And then if I convert this to a fraction, it will tell me that the chance of me picking a black marble first and then a red marble second is 1 out of 20. No, you're fine. I hit a button and it shrunk all of my tabs that I had open. So it shrunk all of them. So for this one, we'd pick 1 over 20. All right. On number 8, you got number 8 correct. Do you want me to explain it or are we okay? All right, good. All right, next one, number 9. All right, so this question says that an experiment involves drawing a card from a standard deck, replacing it, and then drawing another card. Which event is in the sample space of this experiment? Okay, so visualize kind of what's happening here. We have this deck of cards, right? And we are drawing one card from this deck. I am replacing the card, and then I'm going to draw another card. So how many total cards am I drawing? If I'm drawing one, putting it back, and then picking another, how many total cards am I drawing here? Well, I have 52 total cards, but I'm only drawing 2, right? Because I'm picking one, putting it back, and then picking another. So I am drawing 2 cards, right? Am I drawing them from the same deck of cards or are they from separate decks of cards? Are they from the same deck or separate decks? The same deck, right? So I am drawing 2 cards at the same time from one deck of 52 cards. All right, next question says, which events are compound events? Select all that apply. So remember, compound events are events where you're doing more than one thing, right? So this first one says drawing a card that is an ace or a 2. The next one says rolling 2 dice that both land on an even numbers, rolling a die that lands on 4, or flipping a coin that lands on heads. So out of those, which ones do you think are compound events? So which ones do you think are compound events? The second one and the first one, so these two here? Yes, you are correct. So drawing an ace or a two and then rolling two dice and that they both land on an even number. Perfect. You are very correct. Because both of them have two separate things that are happening. Perfect. All right, next one says that Tony flips a coin and gets heads. He tells his friend that he can get two. Sorry, let me restart from the beginning. Tony flips a coin and gets heads. He tells his friend that he can get heads two more times in a row. What is the probability that Tony will flip a coin and get heads three times in a row? Okay, so he's saying that he is going to be able to flip a coin three times and it lands on heads every single time, right? So he's doing three experiments technically, right? He's doing three different trials. So we have trial 1, trial 2, and trial 3, right? And each time he has 1/2 of a chance of it happening, right? Because each time he has a 50-50 chance of it landing on heads, right? So here, the question is saying, what is the probability Tony will flip a coin and get heads three times in a row? So you're very close with your thought process, but this is where you have to make sure you're being extra careful. So these are the three probabilities that I have, right? I have 1/2, 1/2, and 1/2. So when you see and, you are multiplying your probabilities together. You're not multiplying it by 3. Because yes, you're doing it 3 times, but we're multiplying the probabilities from each of the trials. So I would have 1/2 times 1/2 times 1/2. Yes, exactly. So if we do 1/2 times 1/2 times 1/2, we will get 1/8. So 1 times 1 times 1 is 1. And then 2 times 2 times 2 is 8. So for this one, we would get 1/8. Yes, exactly. So your thought process was correct. We just have to remember that we're multiplying the probabilities, not the number of trials by the probability. All right. Next one says, which event is a compound event? Remember, compound events have more than one thing happening. First one says flipping a coin that lands on heads. Second one says landing on a green section on a spinner that has blue, green, and red sections. Rolling a die that lands on a 5. And then selecting a blue or green marble from a bag of blue, green, and red marbles. So this one only has one right answer. So between those two that you guessed, one of those is correct. The fourth one, perfect. Yes, because it's saying it's selecting a blue or a green marble from a bag that has blue, green, and red. Perfect. Yes. The second one is not, because it's only landing on one section of a spinner, versus down here we're talking about picking two different color marbles. Perfect. All right. 13. Ooh, this one's fun. Okay, so a wireless store offers these different cell phone bundles, right? They have different plans, different cell phone types you can pick from, and then a free gift based off of whatever plan that you choose. We want to know what is the probability that a customer selects the 2-year contract, a smartphone, and a $25 gift certificate? So since we see that word and, that tells me I'm going to be multiplying, right? So what we need to do here is figure out the probability for each one of these columns. Okay. So for the cell phone plan, when I look at this first column here, how many cell phone plans does the customer have to choose from? So he has 3 cell phone plans to choose from, right? Pay as you go 1-year contract and 2-year contract. So he has 3 total cell phone plans to choose from. Out of those 3, how many of them are a 2-year contract out of those 3? 1. Perfect. Now let's look at the next column for cell phone types, right? For cell phone types, if he is picking a smartphone, how many out of the total number of smartphones, what would be the probability of him picking a smartphone from this middle column here? 1 out of 5, perfect. And then what about the very last probability, looking at this column over here, picking a $25 gift certificate? 1/4, perfect. There's 4 total options and only one of them is a $25 gift certificate. So now, since our problem used the word and, that means that we are going to be multiplying, right? So all we need to do is multiply these 3 fractions together. So I have 1/3 times 1/5 times 1/4. And if I hit this button and change it to a fraction, I get 1/60. So that means that they have a 1 in 60 chance of a customer that selects the 2-year contract, a smartphone, and the $25 gift certificate. All right, almost done. 2 more. Oh, there's so many options for this one. It says, which answer best describes how to calculate the probability of the following compound event: drawing a red 5, a 5 of hearts, or a 5 of diamonds from a standard deck? Okay, so in the parentheses here, this is our compound event, right? I'm drawing either a 5 of diamonds or a 5 of hearts. So am I looking at an and or an or probability problem here? Which one is it? And or or? Or, which means I'm going to be adding or multiplying. Adding, perfect. So right off the bat, these 2 answer choices that say multiplying, I'm going to cross them off. Now, when you read the answer choices, they're the same, except the only thing that's different is the suit, right? This says 5 of clubs and 5 of diamonds, 5 of hearts and 5 of spades. The question is asking us for 5 of hearts or 5 of diamonds. So you just want to make sure that you pick the answer choice that says 5 of hearts and then 5 of diamonds. So just make sure that your answer choice has hearts and diamonds, since that's what our question is asking. Yeah, so double check it to make sure. Yes, one more. All right, which answer correctly describes the probability of flipping a coin twice in a row and having the coin land on heads twice? Okay, so just kind of talking about this, we're flipping the coin 2 times, right? So let's do what we did for that one problem, right? Here's trial 1 and trial 2. Both times you have a 50-50 chance of it landing on a tails. Nope, heads. Both times you have 50-50 chance, right? So the probability question is using the word and, so that means we would multiply. So I'd have 1/2 times 1/2, which would give me 1/4. So 1/4 is smaller than 1/2. right? So it's not impossible. It can definitely happen, but it's unlikely because you only have a 25% chance of it happening. So your thought process of even wasn't necessarily wrong because technically it is a 50-50 chance, but the more that you flip your coin, the less chance you have to keep landing on heads.